Welcome to week 3. This week we're going to be talking about what is out there outside of our own solar system. We have exoplanets, and also, since this is a critical thinking course, we're going to talk a little bit about conspiracy theories this week. All right, so let's get started. So you can see here on the left, a grossly out of size and scale, now that you have a little bit of a sense of size and scale, representation of our solar system, and some information here on the right. So Uranus and Neptune were not discovered for a very long time in relation to the rest of the planets in our solar system. They're very far away. You cannot really see them without an aided eye. So you would need a telescope to see them. And in 1781, Herschel found Uranus, and it wasn't until 1846 that Neptune was discovered. And the reason that they found them was they finally came into view. It takes them forever to revolve around our sun. So Uranus, 84 years. And Neptune, over 164 years it takes it. And this, a year meaning like it takes us 1 year to go around the sun. It takes Neptune 164 plus years to go around the sun. So if you're not looking in the right spot at the right time with a telescope, with an aided eye, you're not going to see these planets. It makes sense that we wouldn't have found them for a very long time. So it took that long just to find planets in our own solar system. So it's pretty remarkable that now we have the technology to find planets in other solar systems going around different stars that are not our sun. And that's what an exoplanet is. We have several different ways that we can find exoplanets. They're listed here on the screen. The one that we talk about most is transit. It's the easiest one, in my opinion, for most people to understand, but they can also find them other ways as well. So let's take a look. So finding an exoplanet through this method of transit is waiting for it to pass in front of its star and block some of the light. So we can map the brightness of a star, and then if that dims over a certain amount of time and then pops back up to its original brightness, then we know that something has gone in front of it. Here we go, it's bright, it's bright, it's bright, and then, ooh, it's dim. And then it goes back to its original brightness. Then we know that something has passed in front of that star and blocked a little bit of the light. You can imagine somebody like in a movie theater walking in front of the screen and blocking a portion of the screen. There's not as much light reaching your eye. And that's kind of the most simple way of explaining transit for how we look for planets going around other stars. Now, the interesting thing about this and what you might want to think about is what type of planet would we be able to spot? For example, would we be able to see Neptune in our solar system that takes 164 years to go around our star as easily as we would be able to see Earth, which takes 365 days, 1 year to go around, or Venus, which I believe is only 88 days to go around our sun, right? It would be much easier to see Venus because it's passing by much more frequently. So the types of stars, the types of exoplanets that we find going around a star are the types of planets that are very close to their star and that are revolving very quickly. So that if we're looking over the course of a couple of weeks, a couple of months, we're going to see it pass in front of its star more than one time and be able to confirm that it's there. Clearly, we're not going to find the planets that take decades and decades to revolve around their stars. Here's just a little video image of what it looks like. So there goes the planet in front of its star, the brightness dips, and there you go. There's another way that we can find exoplanets, and that is by looking at the star itself. So stars have gravity, and planets also have gravity. So our star has gravity, and it pulls on its planet, which also has gravity, but the planet also pulls on the star. They affect each other. And so the star is affected by the planet going around it, and it will wobble back and forth based on the amount of gravity and also the amount of planets going around it. And we can detect that by looking at the star. So we can see when the star is coming toward us, we get blue shifted light. So blue shifted light happens when an object is moving toward us. It tends to be in the blue range of light. This is called the Doppler effect, actually. And as it's moving away on the other side, it gets red shifted. And so we can see as a star moves from blue to red, we can figure out its wobble. And with a little bit of math, we can figure out if they're, how big an exoplanet is, maybe how far away it is from its star. So that's another way. It's called the radial velocity method. So radial velocity is just another quick overview, shifting blue and shifting red. There are several types of exoplanets. We like to equate them to the planets that we know best, which are the ones in our solar system. And so the terrestrial planets are the ones that are Earth-like. They are pretty much about the same size as Earth. They are rocky. Sometimes they have atmospheres and oceans, that sorts of things. We like these types when we find these types of planets. It's very exciting to exoplanet scientists because there's possibility life could be there. Very cool. Then they have super Earths that are similar to Earth, but they're big. They're rocky. They're more massive. We have ones that are like Neptune and Uranus. They call them mini Neptunes. We don't have any of those in our solar system. And then, of course, gas giants that are like Saturn, Jupiter. They call them hot Jupiters. Planets like Jupiter itself is a failed star. And so hot Jupiters are also failed stars. They're easier to spot if they're really close to the star that they're orbiting. So it would be different than what is found in our solar system, because planets like this that are in other solar systems going around other stars, it's odd because there's a Jupiter-sized planet very close to the star that it is orbiting, thus the word hot Jupiter. So this is just the way that they classify exoplanets. These are the types that they found. Just an image of like how many. Every dot that is there is another exoplanet that has been found. They go up every day. There's an exoplanet app that you can load to your iPad or phone, and it tracks, the daily tracking of exoplanets. I think we're in excess of about 6,000 or 7,000 logged exoplanets to date. Clearly, the big ones are easier to find when they're orbiting close to their star, but you can see the different ways that they have been found over here on the side. And the rocky planets are the ones we're excited about because those are ones maybe that could have life on them. Ocean worlds, too, are pretty cool because, again, if there's water, there might be life. Hot Jupiters are easy to find because they're orbiting close to their star. And so just a little idea here. And you can see down here, like I talked about a few moments ago, that the orbital period has to be pretty short. It has to go around its star pretty quickly in a day, 10 days, 100 days, or else it's going to be really hard for us to find it because our time is limited in order to be out looking for things that are orbiting other stars. So there are the Kepler mission actually just took one little square of the sky and looked at it for a very long time. That program actually stopped collecting data because the Kepler telescope malfunctioned, but it gave us some of the really coolest planets that it found. But you can see here, for example, this is Kepler 62. They just started labeling them all in order. And Kepler 62 had all of these planets in it, which is really neat. And so the habitable zone is, they call it like the Goldilocks zone. It's not too close to its sun. You're not too far away from the sun. You know, if you're too close, all the water burns off because you're too close to the star. And if you're too far away, you're just a block of ice. And so there's not going to be any life living there. So they like this Goldilocks zone, which is where we live. And actually, Venus, Earth, and Mars are all in the Goldilocks zone for our solar system. But this was kind of neat for this Kepler 62. There were 2 planets there that were in the habitable zone, which is neat. And then these other ones, of course, they found because they were very close to the star, and they could detect them going around, which is neat. And 2 of them were actually very big. It's just an interesting little example of some of the systems that we have documented. And then again, this is just another way to determine what type of exoplanet they have found. This one here, you can see if it has an atmosphere or not based on what the light looks like when it gets back toward us. So a planet that has a thicker atmosphere and a planet that has a thinner atmosphere is going to give us a different fingerprint of light coming back. And so scientists have a good idea of what's going on that planet. Pretty remarkable for things that are so far away. Again, this is just another image. We've got to scale of our planets here on the right-hand side with Earth and Mars and Neptune and Jupiter. And then over here, this is distance from Earth in light years. And so the closest one is 4.2 light years away, and then we get all the way to thousands of light years away. And that is if we could travel at the speed of light, which we cannot even come close to traveling at the speed of light. It would take us 4 years to get there for the closest one. So we are not getting to any of these exoplanets anytime soon. These are artist renditions of what these exoplanets may look like based on their information they've collected about them. And so they're not photographs. We cannot send a probe there. These are way too far away. Interesting, though, about how they might be Earth-like, just to think about, you know, if there's life happening somewhere else in our universe. This is just another little, I did a quick screen grab of the Exoplanet app. It's a cool app. It's got all kinds of things on there. Part of it will give you a size comparison. It's not how far away they are, but how big they are compared to each other. So this was a cool one, Kepler 101. And so there's our sun, and I'm just scrolling around. Excuse, it's a little choppy, sorry. But it shows you all of the different planets that have been logged going around that Kepler 101 star, and about how big they are if you could put them into our solar system, what it would look like in comparison. So kind of cool. All right, so let's dive into conspiracy theories. Coming along with exoplanets, we can talk about, you know, if I say there's an exoplanet out there and I say, is there life out there? Immediately, we probably think, oh, wow, are there aliens? And have aliens been here today? So I thought exoplanets and conspiracy theories and things like wondering about aliens and all of that would go nicely hand in hand. And maybe just stop for a moment and think about in your class, are there conspiracy theories that come up in your class frequently? For me, it's always that the moon landing was faked. which it was not. But that's the frustrating one, that there's still so many students that come in saying that because it's generational. Like entire families think that that happened and they pass that information down to each other. So let's dive in. Here's a few. I'm curious, out of all of these, are there any that you have dabbled in your brain? And I could say for sure, in my lifetime, I have wondered about Area 51. Um, Big time, my husband is into the JFK, for sure. It was a conspiracy. I didn't know really about this Princess Diana one, that people think that she was murdered. Bigfoot, of course, when I was a kid, we talked about that. Everybody loves to think about UFOs. When I was a kid, people talked about the Loch Ness Monster a lot. And then there's a lot of, there's some current ones, constant conspiracy theories happening. 9/11, that it was an inside job. And then all kinds of conspiracies around COVID-19. The Illuminati is, controlling it, things like that. So let's not be too judgmental, because there might be some things on this list that you believed in as well, but let's take a look at why it feels good to our brains to do this and maybe how to combat it in our classes. So they're not just here in America. You can read what's on the screen here, but it is worldwide. And at the bottom here, you can see that these percentages of people down here on the bottom believe there is a single secret group of people who control world events. I mean, wow, 78% of people in Nigeria believe that. Like, these are not small numbers. So, believing in a conspiracy theory, like, why? So it can be very empowering, especially for people who feel powerless. So people who believe in conspiracy theories experience a feeling of acceptance within their communities of like fellow conspiracy theorists, especially now with the internet. You could pop online and really just get validated for your thoughts and your feelings about these theories. And they can develop like a sense of superiority over those who don't believe in the conspiracy theory. Ooh, you don't know what I know. People like to believe in them because it explains unlikely or big events. People don't like mundane or boring scientific explanations of things, or a lack of an explanation, like if we really just don't know. So a conspiracy theory can satisfy their need for something to have a significant cause, or a satisfying answer. They're very compelling. We get drawn in. Ooh, it's not what you thought. It was a much bigger thing, like you're watching a movie. It's interesting. It uses simple language. Sometimes there are videos and images, often now actually with the internet, that can trigger emotions and be a lot more relatable than elaborate science or like a complex news story. People get bored and they shut it off. They want it to be interesting. And once you start to believe in conspiracy theories, you're more likely to just keep believing in conspiracy theories. It's sort of like if you know that one negative person who's just constantly negative, that they just find everything wrong in the world. It becomes a pattern of thinking. So people that believe in conspiracy theories rarely believe in just one, but it's like a complete worldview. Because they follow a common structure. They have a group that orchestrates a secret plot, right? There's a hidden agenda. There's a cover story to hide it. And then a group that helps implement it. And that can be very easily transferred from one thing to the next. And so it's easy for people to continue to believe in conspiracy theories. They all have that pattern. So they actually can do damage. You can see this list here on the side, but they favor black and white thinking, and they can be used to target entire groups that are perceived as the enemy to be a real or an imagined threat. Um, and it can fuel discrimination, it can justify hate crimes, it can be exploited by really extremist groups. I'm sure you can think of a few things yourself right now when thinking about that. And really, it can fuel violence. Excuse me. It can fuel violent extremism. They can use them to recruit people and justify violence. And according to research from the think tank Demos, violent extremist groups are conspiracy theories across ideologies for at least 4 reasons. They can demonize out groups, they can victimize in groups, they can delegitimize voices of dissent, and they can encourage a group to return to violence, allegedly for self-defense. So they really can do damage. So it's not just like a fun thing to think about. When people really get wrapped into this, it can fall apart real fast. So there's lots of ways to identify a conspiracy theory. Typically, a quick Google search can give you the information you need. But there are groups working very hard to make sure that conspiracy theories get debunked, and that real information gets out and gets rid of misinformation. So you can see this little list here. The conspiracy theories are contradictory. The official account of the event is just wrong. That's where they start. Is that, whatever they're saying officially happened? Nope, that's not what happened. There's an overriding suspicion. So having skepticism is fine, but it goes to like extremes. There's nefarious intent. So, there's some sort of evil villain. And then something must be wrong. Like the official account of the event is just flat out a lie. Somebody's lying. Typically, there's a persecuted victim. And so conspiracy theorists see themselves as victims of organized persecution. So they believe that there are brave heroes fighting against, the odds to bring down the all-powerful conspirators, completely immune to evidence. And randomness. There's unrelated events that are weaved into a broader interconnected pattern. And so, it's hard to fight that because it's all over the place. So what do we do? What do we do with our students? What do we do with our families? They say with students in an education, the reading that I've done, that pre-bunking is good. Try to get ahead of it. Get the right information out there before people become hooked into a conspiracy, if that's possible. And then once they are hooked into something, to debunk it as best you can. And so empathy-based debunking calls attention to the target of a conspiracy theorist and the potential conspiracy theories causing harm and violence. Source-based debunking decredits those who are spreading the theories, and hopefully leading the learners to distance themselves from it. So just providing evidence, which of course can be debunked as well. I've provided on Schoology some games actually that you can play with your students. There's one called Crazy Uncle, because of course we all have a crazy uncle. And then there's another one called Go Viral. It's about anti-vaxxers. That came out of the COVID-19 pandemic. And so both of those I thought were really good. And then I'm going to go back to that one. There's really a call to action with this pre-bunking of trying to get educators and organizations and governments and scientists to really get the message out there ahead of anything, wrapping into some sort of conspiracy theory, and then also going to the places where these theories are being spread and trying to, if it's too late to pre-bunk, to debunk. So I think as teachers, we're in a unique position where we can really start to give kids the tools and go ahead and try to debunk the things that kids are thinking about. Okay, so on Schoology, for week 3 under exoplanets, the first thing I want you to look at is this little piece of research here. And if you see at the top, there's some great graphics on the bottom. This is from the United Nations, there we go, Educational, Scientific, and Cultural Organization. And they have put together, really, this is a great document that I think you should kind of flip through about conspiracy theories, and it's specifically written for us. And so take a look at that first, and then what I did is I pulled off a couple of different graphics from that for you. And so how to address them specifically in the classroom. So you can see here, this is like a one-pager. And then I also pulled off this graphic for you too about thinking before sharing that you can give to your students directly. And so all of those are linked here underneath. Then also I found a really good parent guide, which has excellent information for us as educators as well. And then also if you're a parent, it's cool. The poster's there. So I have found just a ton of things online for you to look at. Here are the games. Here's the Go Viral game and the Cranky Uncle game. That's really good. Or I think it's called Crazy Uncle. I'll have to change that link there. How to argue with a conspiracy theorist and win. And then I've just put a couple of the things here that from that first slide about, you know, JFK and the moon landing and Area 51. And on the bottom, there's a story. It's a pretty quick story, maybe about 5 minutes or so, of someone who was just completely wrapped into so many conspiracy theories, and she found her way out. I thought that was very interesting. So for week 3, it's going to be very similar to the prior weeks. You're going to choose an option. Make sure that you go back and comment on a couple people's, collaborate with each other. And so for option 1, you're going to talk about maybe how you would address this in your classroom. Conspiracy theories. Are there movies, books, ideas, online content that are seeping in and that you find yourself addressing year after year in your classes? And so maybe what you would do, a lesson plan, a student assignment, something like that. And then option 2 is, what about in your world? Is there a conspiracy theory junkie in your world? Maybe you're a conspiracy theory junkie. You know, what have you believed? And there's a list to help jog your memory of some common theories. And then using the ideas that you learn about here and digest for a little bit, convince maybe yourself, your friend, your relative, and you can maybe write up a note, or how about this, have an actual conversation, and how you would combat that. And so in short, you're going to pre-bunk or debunk a conspiracy theory in your life for you or someone you know, and attach a well thought out written argument. So it's kind of nice to have that in your back pocket for the next time you're at a family party maybe. So enjoy diving into exoplanets, aliens, and conspiracy theories.